Let's talk about language as tool to communicate with computer. In the previous video, we discussed languages and their connection to memory and microprocessor. Now, let's explore this topic further. This is programming language, this is programming language, this is programming language, this is HTML. In digital technology, information is typically carried by electrical voltage. Two voltage levels or intervals are used. The high level voltage is voltage close to supply voltage. And the low level is usually close to 0 volts. The low voltage level typically represents a logical 0, and the high level represents a logical 1, which allows information to be encoded in binary. You might ask, okay, but why binary? Isn't it more natural to use decimal system? 1, 2, 3, 4, 5, 6, 7, 9, 0. The answer might be clear from this picture. We have two levels, low and high. There are quite wide ranges, with even wider in the middle. We need this because we must be certain between 0 or 1. If we were to divide this interval to 10 separate parts, it would be difficult to maintain reliable distinction without a significant increase in voltage. Now you know why we use zeros and ones in computer science. We began our conversation with machines around year 1800. At least that's the case when we talk about automation. It started with Joseph Mary Jacquard. It might be surprising, but already the first time speaking about automation was in textile industry. Jacquard constructed loom. The Jacquard loom utilized the punch card to control the weaving process. Each punch card represented a specific pattern, allowing the loom to automatically follow the instruction encoded in the card. This automation was a significant advancement in textile manufacturing. The machine aligns rods with the specific locations in the card. When the card is pressed against them, nothing happens if there's a hole. The rod passes through. However, if there is no hole, the rod is pressed, functioning like a button, which causes the thread to be lifted. I've included a link that provides a detailed explanation of how Jacquard's loom works. By the way, the picture on the left was woven on the loom using 24,000 punch cards. Among many other people, the Jacquard loom was interesting to Charles Babbage. He was very inspired by the machine, and he saw a future and potential possibilities in the punch cards. Babbage designed difference engine. He was using the punch card but in slightly different context. In the difference engine, punch cards were primarily used for inputting data, such as constants of coefficients needed for mathematical calculations. The machine itself was actually used for tabulating data, or let's say tabulating the results of the formulas. Unlike the Jacquard's loom, the difference engine operations was fixed based on specific mathematical function it was designed for. However, both of the machines used punch card in similar way to send the data. Here is interesting letter praising Babbage for his machine, Babbage's new machine for calculating and printing mathematical and astronomical tables. It's time to talk about first programmer, the first software developer ever, Ada Lovelace. She specified a method for Babbage's second machine, the Analytical engine, the method for calculating Bernoulli numbers. This is recognized as the world's first published computer program, and this was back in 1840s. Unfortunately, both machines were never fully constructed during the Babbage's life, due to fundings and also technical limitation of his era. Computer punch cards in his machines were read electronically. The cards moved between brass rods, and the holes in the cards created electric current where the rods would touch. As was mentioned, Ada created first computer program. Thus, for Babbage's analytic machine, we can talk about punch cards as being used to specify computer program, not only to send data. You will see in the next episode what is the connection between data and the program with respect to memory. So now we have medium to communicate with the computer, the punch card. This changed over time to tapes, floppy disks, CDs. We have methods to write on them using punchers, keyboards or touch displays. Now we shall talk in details about programming languages themselves. We can divide them based on various metrics. Here I'm going to divide them based on generations. First generation. They are low-level languages like a machine language. They are machine-dependent and the statements are written in binary code, only zeros and ones. This is actually very similar to what we talked about last lesson. They are fast and efficient as the statements are written as close to hardware as possible. However, they are very difficult to learn, very difficult to maintain, very difficult to debug, to find potential mistake. First generation is the lowest possible level. It corresponds directly to machine code of the target microprocessor. Here's an example of machine language. The first number represents 176 in decimal. Let's say that the second group of numbers, the second group of ones, is a code for addition. The last number represents 97 in decimal. the machine would understand that we would like to add two numbers, 176 and 97 together. Each single character is called 1 bit. The value of 1 bit can be 0 or 1, as we know. As you might notice, I'm using groups of 8. This is not random. 8 bits have specific place in computer science, and we call them 1 byte. So in this case, we talk about 3 bytes representing number plus number. Second generation. These are low-level assembly languages used in kernels and hardware drivers. Assembly language contains human-readable instructions. However, these instructions must be converted to machine language for the machine to understand. For that, we use a program called assembler. Programmers can write the code using symbolic instruction codes that are meaningful abbreviations of mnemonics. It's way easier to understand compared to machine language. Assembly language is a more human-readable view of machine code. Here's an example that adds two numbers. You can see that this is again something what we discussed last lesson. We are going to move number 5 to specific register, to specific place in the memory, and we are going to add number 3 to whatever is in the memory already. Third generation. We call them high-level languages. This might be a little bit misleading today, because in comparison with the modern languages, they really feel more low-level than high. We can mention C or C++. Also Java belongs here. They consist of the use of series of English-like words that humans can understand easily to write instructions. For execution, a program in this language needs to be translated into machine language using a compiler or interpreter. You know, the machine language is something what we must always achieve. This is the thing what machine understands. All of this generation just trying to make life easier for a human, for a programmer. Thus, for the second generation, if you have code in assembly language, you need assembler to translate your code to machine language. Here in the third generation, you need compiler, again, to translate the code what you wrote to machine language. We might talk in another lesson what is compiler, what is interpreter, and what is assembler. Imagine it's just a program which translate whatever you write to the language understandable to a machine. The higher level languages are more abstract. They are not tied to specific hardware. You can see example. This might look a little bit intimidating, but if you take a look, it's not that bad. We have variable A, variable B, and we are counting their sum. We are basically doing the same thing as in the previous example, but I believe that written it that way is way more obvious. And this is what is it about. Make it easier for the programmer. Fourth generation languages consists of statements which are even closer to way how humans talk. They are used mainly in database programming or scripting. Examples could be Perl, Python, or SQL. They tend to be specialized towards very specific programming domains. Fourth generation languages are even more abstract and often focus on a specific problem domain. They are designed to reduce programming effort and minimize the complexity of the code. Here's an example of SQL. We have select star from employees where salary is bigger than 50,000. This is already very abstract for the computer, but I believe it's very understandable for human. Imagine you have a table, Excel sheet as you know, name employees. There are lots of rows with a name, address, position, salary. And you are interested to see only these rows where is a person with salary higher than 50,000. Easy as that. The last one, fifth generation, is even more abstract. These are programming languages which frequently have also some visual tools to help you build the program. Example of the fifth generation programming language can be Mercury or Prolog. The group itself contains languages which are specified on problem solving rather than to algorithm how to solve the problem. They may even use artificial intelligence. They focus on constraint-based and logic programming. Here's an example in Prolog. We have father, John Jim, father, John Ann, and definition of sibling. This might be already a little bit cryptic. The first statement means John is Jim's father. The second line means that John is also Ann's father. And the definition of sibling reads as X and Y are siblings if there exists some Z such that Z is the father of both X and Y. In Prolog, we can use facts and rules to make queries. For example, we could ask the Prolog interpreter who's Jim's sibling by querying sibling, Jim, who. Given the facts and the rules we defined, the interpreter would return who is equal to N. So, the first two generations are called low-level languages. The next three generations are called high-level languages. Generally, each generation of development introduced more abstraction, distancing developer from the underlying hardware. The focus shifted from how to do it to what to do. Here's a final tip. If you are considering starting with software development and unsure where to begin, I recommend to choose 4th generation language, such as Python. Its environment is easy to set up, the language itself isn't overly complicated, and it will provide useful foundation if you later decide to switch to 3rd generation language, such as C++. That would be all for today. Thanks you for watching and see you next time.